Many years ago, someone anonymously gave me this origami paper crane that says to eres el dx de mi integral from a to b of f of x. And it was the combination of all things I love. I love Spanish. I love math. I love just how clever it is, the whole thing. And to me, you are the dx to my integral from a to b of f of x. And so to me, it means without you, I'm nothing, or you complete me. And so I was so proud of it that I, showed my students this. And one of my students who was not a fan of good notation, he decided to interpret it in his way. And he said, "Oh, does it mean you're really not important?" Or "I don't really need you." Anyway, that's not my interpretation, but all right. So let's talk about this form here and what's the problem with it. So the number one problem with it, my friends, is that does 2x minus 3 have x minus 1 times x minus 1 as its factors? Absolutely. But with this repeated linear factor, if you go with exactly what you see here, what is the least common denominator? The least common denominator between x minus 1 and x minus 1 is x minus 1. It is not x squared minus 2x plus 1. And a lot of people think, well, so what's the big deal? How is that even a problem? Well, let's kind of go through the motions of trying to do our partial fraction decomposition, right? So we would take a over x minus 1 and multiply it by x minus 1 over itself, right? Oops. And we take b over x minus 1 and we'd multiply it by x minus 1 over itself. Okay. And then what would we have? We'd have ax minus a plus bx minus b all over x minus 1 quantity squared. And at that point, I have won the denominator battle, right? Or it looks like I have. So if I try to win the numerator battle and set 2x minus 3 equal to a plus b x plus negative a minus b, and what would I have? I'd have a plus b would have to equal 2, and the opposite of a minus b would have to equal negative 3, which, by the way, that second row is, if I divide both sides by -1, it would be saying a plus b has to equal 3. And right there, I hope you can see the problem. How can a plus b equal 2 and a plus b equal 3 at the same time? And so you have this contradiction here. Unless you want to go back and teach all the kindergartners that 2 and 3 are actually the same number. Anyway, so you're going to run into problems if that's the form. So there you go. That's the long answer. The short answer is if you have what's called a repeated linear factor, so we had x minus 1 2 times, then it just changes the form. So you'd want to change the form so that your least common denominator is the denominator you're aiming for. And here's how you fix it. You would just make one of the forms be the quantity x minus 1 squared. It's that simple. So there you go. Anyway, so now you have a form that'll work for a repeated linear factor. And then from there, the process would be the same as what we learned in the first section. So skipping to example 5, what we're going to do is we're going to just talk about what is the form of the partial fraction decomposition for certain situations. So for part A here, we're not going to actually decompose it because honestly, I didn't make the problems up thoughtfully enough. I think we'd have some pretty gnarly results if we tried. But we're just going to make sure that you're okay with what the form would be. So for part A, with this x minus 5 cubed piece, you have this repeated linear factor. So to set the form, you'd have a over x plus b over x plus 2. So those are distinct. So you just kind of do your normal thing. But now for the repeated part, you're going to have a constant over x minus 5 plus a constant over x minus 5 quantity squared plus a constant over x minus 5 cubed, like that. So that would be the form for this case where you have a repeated linear factor of x minus 5. Okay. Now for part B, if you had here, you don't have a repeated linear factor. Instead, you have what's called a quadratic factor. And actually, let me add the name of the cases next to each one. So for part A, that was what to do with a repeated linear factor. And then for part B, this one's dedicated to quadratic factors. Hopefully it makes sense, x squared plus 1. If I could factor it down to linears, I would, but you can't factor x squared plus 1 with real numbers. So we would have to leave that a quadratic. So in that case, the form would be a constant over x plus, and then what I'm about to say should make more sense to you now that you are in Calc BC as opposed to Excel or Pre-Cal, but basically, since you have a quadratic factor, since the degree of the denominator is 2, we would put something that's degree 1 above it. So a general, here's your general linear function here with a bx plus c. So now that you're in Calc BC, I hope it makes sense that, we kind of like to let u equal the denominator, in which case we'd want the numerator to be, 1 degree less than the bottom there. So hopefully that makes sense. So this is what to do with a quadratic factor. There we go. And then for part C, this would be a repeated quadratic factors case with this piece here. So we'll have a constant over x. So you've got degree 0 over degree 1. And then you'd have the other two denominators would be x squared plus 1 and x squared plus 1 quantity squared, kind of like we mentioned in the previous example, so that your least common denominator would be the denominator you started out with. And then anything that's degree 2 for its base, you would have degree 1 over it. And then the same thing here. There we go. And so this would be a repeated quadratic factor case. There we go. Okay, so hopefully you feel like you know what to do with setting up the form, and then the rest is the same. So, all right, my friends. You can disregard this little note here because actually we never did do the partial fraction decomposition. All right, so for example 6, let's have you integrate 2x minus 3 over x minus 1 squared. And let's just worry about that for now. We can go on to part B later. All right, see how it goes. Check in with me in the next video.